So dear students, we are going to start our new chapter, that is our current, electricity, which is obviously our third chapter. And I have left or skipped some part of the chapter 2, which I haven't completed, or I unable to complete it in the video itself. So because that is very much practical and it's hard to explain in the video, so that I've decided now to start with our chapter 3, that is current electricity. So hope you guys follow this chapter. So this chapter is somewhat easy for you because you have already studied the basic part of this chapter in your earlier class, that is class 10 itself. So basically it is about electric current and all. So first of all, current electricity, we are going to define what is electric current in this introductory video. So define electric current. Define electric current. So basically, what is electric current? So electric current is the number of or the rate of flow of electric charge. So the rate of flow of electric charge is also known as electric current, or you can define it another way, that is the flow of electric charges per unit time is your electric current. So electric current is symbolized by this capital letter I, which signifies electric current. So mathematically this is equals to charge divided by time. So charge divided by time is your electric current, or like in other symbol you can write it as some small amount of charge flowing in a very small interval of time, that is delta t, is also written sometimes. The unit of SI unit of electric current is ampere, which is symbolically written by capital A. So let us make a scenario in which we get an electric current. So how we get an electric current? So basically we can get electric current through electric field. If you can generate electric field in any substance, then you can get electric current out there. For example, suppose you have a conductor. You are well aware of conductor. So conductor is something where you can easily separate negative and positive charges, such that you can generate a potential difference in the conductor itself. For example, if this is your some conductor and you have atoms in there, and if you see microscopically, so you have positive ions or positive centers and electrons, which is negative, revolving around them. So positive centers and negative charges revolving around them. So this is your this is your microscopical view of a conductor or any substance. Basically every substances have this particular configuration, that is positive and negative charge. Now let us suppose this to be a conductor. let us suppose this to be a conductor, this particular system to be a conductor. So I've taken it to be a conductor because there is some reason, so you will know it in later sections. So now if you separate these two charges, that is, you separate negative charges around one edge and you separate positive charge around another edge. Now what will happen? Now from positive to negative charge there will be some electric field going from outward from positive charges and going inward towards the negative charges this way. From positive to negative there is an electric field associated there. Now what will happen is, if there is an electric field associated with this particular conductor, now this negative charges start to flow opposite to the electric field. This negative charges, which are known as electrons, so this electrons starts to flow opposite to your electric field. Now electrons are basically negative charges. That means this negative charges starts to flow against this electric field, because electric fields allow any negative charge to flow against itself. So now this particular rate of flow of charges will give me some amount of current inside this particular conductor. So if you calculate the amount of this electric charges flowing per unit time, then you will get the value of the current. So what will happen? This particular electrons will, after some time, this electrons will start to flow from this side to this side. So all the electrons will start to flow this direction towards this direction. That means after some time this electrons will neutralize the positive charge of this side. So after a while what will happen is, all the electric charges from this side will approach or will come to this end. Then what will happen? This will neutralize this one. Then again you'll get a system of neutral separation, or you'll get the net amount of separation to be 0. You'll see the random orientation because this perfectly neutralizes this particular charges. Then you'll get this regular system where the current seems to be 0 again. Here current has some value, that is because in this case electrons are flowing, so you'll get some value of current, I is equals to Q by T, but after a while you will get again your stable system. So when you separate this particular electrons from this positive ions and leave it like that, you'll get after some time you'll get the redistribution, and you'll get again the stable system once again, which was earlier. You will attain its earlier stable configuration. You'll just get the value of current very momentarily, because they were separated first, and after a while they will flow towards the positive charge and they will again stabilize the system. So you'll get only the momentary value of the current. So what to do to get a continuous value of the current? So to get a continuous value of the current, so this is just a momentarily current. In this case, momentarily current, we get current for a moment only. So to get a continuous current, what we have to do? You have to maintain to get a continuous current. To get a continuous current, you have to maintain the negative charge in this particular and positive charge in this particular case. That means as starts to electrons flow from this side to this side, the value of the electron shouldn't be decreased in this case, because if you leave it like this, it will neutralize the system, so the current will become 0 after a while. But if you supply continuous negative charge from somewhere else, then it has a surplus amount of negative charge. And if you supply positive charge from some outside source, then it will retain its positive charge in this case. Then electron starts to flow, you will get current. And if this electrons continuously flow, then you will get the continuous current if you maintain the negative charges in this A's for a long time. So that particular work is done by your battery. So what battery basically do, or cells basically maintains the, if you have a cell, suppose you have a cell, what cells, and if you, this is your conductor, what is the work of a cell? The work of a cell is to maintain the positive and maintain the negative charges in this particular ages. So cell maintains the amount of negative and positive charges around its ages such that you will get the continuous amount of current in the circuit. So electrons will flow from negative to positive charge and current will flow from positive to negative charge. So the work of the cell is to maintain the amount of charges such that you will get the continuous amount of current. So I forgot to tell you one thing, that is if electrons flows from negative to positive direction, if electrons flows from negative to positive direction, then current will flow from positive to negative direction. So current is basically the direction which is opposite to the direction of the electrons itself. So this is your introductory part. Tomorrow we'll continue with our discussion, and that will be about your Ohm's law. Thank you.